The Xpeng iron humanoid robot is one of the clearest signals that robots are moving out of research labs and into real-world work. In this deep dive, we are going to unpack what iron is, what it can actually do, how humans stay involved in the loop, how it compares with the NEO home robot, and what we know so far about pricing and availability. Read this verbatim. Xpeng is best known as an electric vehicle company. With iron, they are making a very direct statement. They are no longer just a car maker. They are a physical AI company. Iron is their flagship humanoid platform. It is built to move, look, and behave in ways that are extremely close to a human, not as a sci-fi stunt, but to function in spaces that were designed for people. Showrooms, offices, industrial sites, and eventually public venues. The idea is simple. If you can operate safely and fluidly in human spaces using human tools, you can be dropped into almost any environment without rebuilding the world around you. Physically, iron is roughly human-sized, about 1.70 meters to 178 in height, and around 70 kilograms in weight depending on the configuration. It is designed around a bone-muscle-skin architecture. That means a central spine for balance and flex, artificial muscles driving its joints, and a flexible synthetic outer skin that hides the machinery and makes contact with people less harsh. The latest public specs describe on the order of 82 degrees of freedom across the body, with highly articulated hands at human scale, offering around 22 degrees of freedom. In plain language, this is a robot that can move its shoulders, elbows, wrists, fingers, torso, hips, knees, and ankles with a fluidity close enough to human movement that people online literally questioned whether there was a person inside it, until Xpeng engineers opened part of the shell on stage to prove it was real hardware. That motion is powered by Xpeng's in-house Turing AI chips. The newest iron shown at Xpeng's 2025 AI Day runs 3 of these chips, with total compute in the thousands of TOPS range, similar to a top-end autonomous driving stack. That onboard compute is critical. It lets iron run complex perception and control models directly on the robot, instead of streaming everything to the cloud. On top of this hardware, Xpeng runs what they call their physical world AI stack. Multiple large models working together to sense, understand, speak, and act. One model focuses on mapping vision and language into tasks. Another focuses on turning perception into real-time motor commands for all those joints. Another handles natural conversation, instructions, and social interaction. The result is a robot that is not just remote-controlled machinery, but a system that can see, listen, understand a request like guide that visitor to the EV display, or check this area, and generate its own movement plan. Energy is another standout decision. Iron uses an all-solid-state battery architecture in current prototypes, something Xpeng also explores on the EV side. Solid-state batteries promise higher energy density and better thermal safety than traditional lithium-ion packs. For a humanoid operating near people in stores and offices, that matters. It gives iron multi-hour runtime per charge while reducing fire and leakage risks, and it showcases Xpeng's attempt to turn their automotive supply chain and battery expertise into a robotics advantage. So what is iron actually for? Xpeng is deliberately not pitching iron as your laundry-folding dishwashing roommate. At least not yet. Their near-term focus is commercial and industrial services. Think of iron as a high-end, human-shaped service worker. In showrooms, it can greet visitors, explain products, lead tours, and act as a living brand ambassador. In corporate lobbies or events, it can perform reception duties, answer questions, provide directions, or run scripted and semi-scripted interactive experiences. In partner industrial environments, it can assist with inspection, monitoring, and simple manipulation tasks where a human-like form and rich perception help. Xpeng is building iron to be a platform, an SDK and AI stack that companies and developers extend with their own behaviors, much like you would build apps for a phone or a car OS. A key selling point is how autonomous Xpeng wants iron to be inside those environments. Unlike some competitors who rely heavily on continuous remote teleoperation for early deployments, Xpeng emphasizes onboard intelligence and a strong privacy stance. They have even articulated what they call a fourth law for Iron. Personal interaction data should not leave the robot. The vision is that Iron perceives, decides, and acts locally with cloud and factory infrastructure used primarily for model updates and aggregated learning, not raw streaming from every interaction. This is crucial in public and enterprise deployments, where cameras on legs create real privacy and regulatory concerns. Now let's talk about human involvement, because Iron is not magic and it is not AGI. Human involvement shows up in three major ways. First, human oversight. Even if Iron can walk, navigate, and interact autonomously, deployments will be supervised. Organizations using Iron will define what tasks it is allowed to perform, which zones it can enter, how it escalates when uncertain, and when it should hand off to a human. In early rollouts, expect clear operating procedures. If Iron cannot interpret an instruction confidently, it will ask for clarification or defer instead of guessing. Second, human training and configuration. Iron's capabilities are driven by Xpeng's large models plus task libraries created by engineers and developers. That means people will design behaviors, safety policies, conversation flows, and custom skills for each environment. A museum tour guide Iron will be configured and tested by humans. A Baustile inspection Iron will operate under carefully crafted procedures. The autonomy sits on top of a human-authored framework. Third, human governance. As Iron moves into visible public-facing roles, issues like ethics, bias, accessibility, labor impact, and physical safety do not solve themselves. People decide what Iron is used for, how transparently it is labeled as a machine, which data it can store, how incidents are logged and audited, and how frequently software and safety checks occur. In that sense, Iron is more like deploying a new category of employee with superhuman consistency than installing a vacuum cleaner. It demands management. So where does this leave us on pricing and availability? As of now, Iron is a prototype and pre-commercial platform with a clear mass production target. Xpeng has publicly talked about scaling humanoid robots by around 2026 and seeding them first into their own ecosystem and select partners. Industry trackers and analysis sites currently list the Xpeng Iron in a ballpark price tier around $150,000 per unit for early commercial customers. That number should be treated as an informed estimate, not an official final sticker price, but it reflects how Xpeng appears to be positioning Iron as a premium, high-capability commercial platform, not a consumer gadget. Now let's compare and contrast Iron with NEO, the home robot from 1X Technologies, because the differences are important if you are thinking about use cases. NEO is explicitly aimed at the home. It is designed to fold laundry, tidy rooms, put away dishes, run chore lists, and interact casually with families. It has a soft, approachable aesthetic, a relatively light body, extremely quiet operation, and a price point targeted around $20,000 or a monthly subscription. Crucially, NEO relies on human teleoperators in the background to guide it through tasks it cannot yet perform autonomously. Those expert sessions also generate training data so the robot can learn over time. In other words, NEO leans on human-in-the-loop teleoperation as a bridge to future autonomy and is built around living spaces. Iron takes almost the opposite path. It is not being sold as a near-term domestic helper. It is heavier, more articulated, more extremely humanoid in motion and appearance, and oriented towards structured commercial roles where a lifelike presence and strong mobility matter. Retail, hospitality, tours, brand experiences, and some industrial inspections. Instead of teleoperation as the default, Iron leans into onboard autonomy with powerful local compute and a strong privacy promise. Rather than a subscription for households, it is positioned as a capital investment or platform for businesses, likely at several times the cost of a NEO. Where NEO says, "Let us into your home, and our remote experts will help this robot learn your chores," Iron says, "Put this into your store, office, or facility, and it will act as an AI-powered, privacy-preserving, human-shaped service platform trained for your environment. Where Enio's superpower is teleoperated competence in messy homes, Iron's superpower is extreme anthropomorphism, plus a multi-model AI stack tuned for natural interaction and navigation in public and semi-structured spaces. Neo is about domestic utility at relatively low cost, with visible human help behind the scenes. Iron is about premium presence, performance, and local intelligence, with humans mainly designing, supervising, and extending its behaviors, not driving every move. Taken together, Iron is not your personal robot butler. It is Xpeng's bet on what happens when you fuse automotive-grade AI, solid-state batteries, high-articulation mechanics, and human-like design into a commercial service robot that can eventually scale. It shows where high-end humanoid robotics is going, toward platforms that can be dropped into real spaces, trusted with customers, and shaped by developers and operators rather than programmed line by line. The humanoid that lives in your home and does all your chores might cost $20,000. The humanoid that represents your brand, greets your customers, and runs on a 3,000 tops brain in a shopping mall is much more likely to look like Iron. I hope you enjoy this presentation. Please like, subscribe, and share.